Okay, so let's give you guys some more practice. So here, find the derivative of this. Find dy by dx. Rather than using the product rule, use logarithmic differentiation. Okay, so press pause and have a go. Okay, so to do this here, visualize it as one bubble here, and then you've got another bubble here. But rather than using the square root, power it to a half. So it's a half here. So visualize this whole thing here as this thing here. Okay, and then now take the natural log of both sides. That log this side, and then log this whole thing here. That will then give you this. Okay, and then when you're here, if you have the natural log of a times b, then that's the same as the natural log of a take away the natural log of b. So that's plus b. Okay, so this is a plus. Okay, and then that would then and when you're here, you can then move this down here, so that this is your half here, and then now use implicit differentiation. So when you're here, differentiate both sides. So if you differentiate this, it will give you 1 over y times dy by dx, and then when you differentiate this here, it will give you this. But then you've got to do times with the differential of the bubble itself. So this 2 is here. Okay, and then come to differentiate this, it will be 1 over cos of x, and then you've got to times the differential of the bubble itself. So that will be minus sine of x. Okay, so that will take you to here, and then just tidy up. So this gets multiplied to the top, and then this gets cancelled out with this, leaving you just this. That's just this, and then this gets multiplied to the top. The minus here is here, and then this in effect is 10. I suppose you can turn this into a 10 of x. Okay, if you wanted to. Okay, and then that yeah. To tidy up, why is this the same as this? Doesn't matter. So basically this is the same as this, and then just tidy up. So now now you want to get dy by dx on its own. So here times both sides by y. Remember, originally this was a y originally. So y times the whole thing here. So that's this whole thing here. Okay. So you could, if you wanted to, tidy up. This times this and this times this, or you can just plug this whole thing into a graph plotter. So originally the red line here. So originally y was root 2x plus 7 and then cos of x. So that this here represents our, well, the red line here represents our original y equals blah blah. This red line here. The blue line here, I don't know if you can see it, but the blue line here represents a derivative. So have a quick check. So looking at the red line, you see the red line here, it has a gradient of 0 here. So straight down, look at our derivative. Our derivative is actually 0 here. Now looking at the red line here, is 0 here. Straight down, our blue line says it's 0. So it seems to be correct. Looking at this, straight right here, looking at the red line right here, the derivative is 0. So straight up, the blue line does say the derivative is 0. Okay, so our graph seems to tally up with our solution here. So this seems to make sense here. Okay, all right. Next example here. Well, sorry, next problem here. So differentiate this here. Okay, so press pause and have a go. Okay, so to do this here, you could use the product rule, but it's easier just to use logarithmic differentiation here. So visualize this whole thing here as 3 bubbles multiplying with each other. So now natural log both sides, that will then give you this, and then well, you've got, well, when you have natural log of a times b times c, then that's the same as natural log of a plus natural log of b plus natural log of c. So that would give you this here. Okay, and then now differentiate both sides. So this side would be 1 over y times dy by dx, and then when you differentiate this, it will be 1 over 3x, but then you've got to times with the differential of the bubble itself. which is 3. Now differentiate this here, it will be 1 over x minus 5, and then you've got to times with the differential of the bubble itself. Well, the differential here is just the 1 here, so you can, if you want to, times 1. And then the same goes with this one here. Okay, and then now it's just a matter of tidying up. So that will then give you this 3, in a way 3 fractions, and then merge the 3 fractions together. That will then give you this. So basically, in order for you to add fractions, all the denominators have to be the same. So visualize the x as this, and then here times top and bottom by x minus 5 times x plus 7 here at the bottom here, times by the same thing. So it will be times by x minus 5 and so on here. And then this fraction here times top and bottom by x, and then x plus 7, and then x plus 7 here. And then for this fraction here, times top and bottom by x, and then x minus 5 here, and then x minus 5 here. Then all the denominators will be the same, and then you can merge them into one fraction. Okay, and then now times both sides by well, looking at this here, you want to get dy by dx on its own. So times both sides by y. So this was our original y here, and then this fraction here is this here. Okay, so now if you look, so we've got to, so this is y here. Okay, this is so when you are here, times both sides by y. So this is our y here, and then we've got to times it with this. Okay, so this here gets multiplied to the top. This thing here gets multiplied to the top here. Okay, so now we can cancel this out, and then cancel the x out. That leaves us with a 3. So that leaves us with this 3 here times the whole thing here. So that's the whole thing here. Okay, so plot this into your graph plotter, and then it will give you this graph here. You see the red line here was our original y equals whatever it was, and then the blue line here, is our derivative. So now double check. Looking at the red line here, there's the gradient is 0 here. So straight down, the derivative does say it's 0. Looking at the red line here, the gradient 0 here. Straight up, the derivative says it's 0. So it kind of makes sense. And looking at the red line, it's going uphill, so the gradient should be positive. So looking at the blue line, it's in the positive, and so on. Okay, so this graph here gives us an indication that that our solution here is correct. Okay.